So if you have seen or if you have gone through the chapter opens with the introduction to what is meant by motion. Then slowly or gradually are introduced to different kinds of terms that are mainly used in this particular chapter. For example, you are introduced to something called as distance, displacement, velocity, speed, acceleration. Then you have an important topic called as graphical representation of the motion, and followed by the various equations that are used for motion. And last, in the end of the chapter, you have the circular motion as well. So with the limited time that we have decided, or I have decided, that we will be having only this content, that is getting briefly introduced to motion, then getting introduced to terms like distance, displacement, uniform, non-uniform motion, speed, velocity, and acceleration, and then discuss about the equations of motion. So here we are not going to consider the graphical representation and the circular motion because of the limitation of the time. So let's get started. Now you can see that we have already been introduced to motion. You have learned it in your school. You must have read it in the chapter. So the definition says that motion is a change of position. Okay, so with only limited words, it comprises or it covers a huge topic, what is meant by motion. So here, if you see examples, we can say that a moving car on the road, it is in motion. An ant crawling on the floor, also that ant, we can say that it is in motion. Earth revolving around the sun, it is in the motion. And couple of examples that I haven't listed here are when the earth is revolving around the sun, or maybe the earth is rotating around itself, what do we feel? We perceive that the sun is moving from, or it is rising from east and setting at west. Even though we are aware that sun is stationary with respect to the earth and earth is rotating around its axis, so we perceive that motion. Similarly, we perceive, so all of you must have traveled by car or by train. So you must have observed that while traveling, the trees that are planted along the road or the railway tracks, even though they are stationary, when we are moving in the forward direction, those trees, they appear to be moving in the backward direction. So in all these cases, for us, there is a change of position, isn't it? For example, sun is rising from the east, so we see it on the in the east direction in the morning. By the time the day passes, or at the noon, it is exactly overhead. And by the evening, we can see that it is setting in the west. So here we say that we are observing motion of the sun. Why do we say that? Because for us, its position is changing. Okay, but for this standard, or as we are simply getting introduced to this new topic, for us, whatever motion we are going to consider, that motion will be of the object which is actually moving. Okay, and along with that, the motion that we are going to consider will be the motion along a straight line or straight path. So you must have read that the motion can be very complex. So in earlier classes also, you were introduced to different kinds of motions. Like there is a circular motion, rotational motion, periodic motion. Do you recall it? It was there in, I think, 6th standard or so. So there are different kinds of motions: rotational, circular, then periodic, random motion. So such motions are quite complex, but as I told you, we are just now stepping into the world of physics or world of motion. Hence, for the time being, we are going to consider motion along a straight line. Okay. Now, the next part that we come to is distance and displacement. Okay. We come to is distance and displacement. Reva, I think I won't get to know if someone has joined here now. Just a second. Yeah, no one has joined. So I don't know whether I'll get to know. Now I don't think that we'll be able to let in anyone. So we come to the next part, that is distance and displacement. So here the first and foremost part is definition. So in case of science, always remember that you should understand the concept, but whenever you're asked to define or you're asked to write something, your answers should be in the precise, concise manner and having appropriate scientific terms. So when you're asked to define distance, so you can see that the definition is, it is the actual distance covered between the start point and the end point. For example, how many of you travel by road? Some participation I expect from all of you. So how many of you travel by road? Everyone. So Pune, Mumbai is quite a common travel route, isn't it? So let's assume that a car starts in the morning, or maybe we can take an example of a train as well. So I'm not sure whether you're aware of, there are certain trains that run between only Pune and Mumbai. For example, Deccan Queen is such a train. Okay, so Deccan Queen, it starts in the morning from Pune to Mumbai. It reaches that CST, that is Chhatrapati Shivaji Maharaj Terminal. And in the evening, it comes back to Pune. So if we assume the distance between Pune station and CST to be 150 kilometers, so the distance that it would be covering will be, so from Pune to Mumbai, if the distance is 150 kilometers, we are assuming it, okay? So if the distance is 150 kilometers, so in the morning, the train travels 150 kilometers of distance, and in the evening, it covers a distance of again 150 kilometers. So how much is the total distance that it has covered? 300. Exactly, it will be 150 plus 150, that is 300. So it is the actual distance covered between the start point and the end point. Okay, so in this case, coincidentally, both the start and end points, they were the same. But still, it is the actual distance that has been covered, has been considered here. Okay, now I think all of you can recognize that this diagram, it is part of, or it is already there in your textbook, isn't it? Now, if you consider the next term, which is the displacement. So what is displacement? It is the shortest distance between the start point and the end point. So are you aware what is the shortest distance? Which distance?
We could say is the initial position and the final position.
Yeah, but if these are 2 points, point A and point B, these are 2 points, what will be the shortest distance? Will this be the shortest distance? Or will this be?
A straight path.
Exactly. A straight path would be the shortest distance, right? Okay, so displacement is the shortest distance between the start point and the end point. Now, in this case, what would be the displacement? So whenever you're asked questions from distance or to calculate distance and displacement, what should be clear to all of you is that what is the start point and what is the end point. Okay, so in this case, in the example of Deccan Queen, we can say that the start point is Pune and the end point is also Pune station. So whenever the start point and end point coincide, that time, what will be the displacement?
0.
Exactly.
0 kilometers.
Yes, either 0 meter or 0 kilometers. So whenever start point and end point coincide, that time, or they are the same, that time displacement is 0. Right. So here you can see that here we have this diagram which I have borrowed from your textbook. So here we are considering an example of an object moving from point O to A and from point O to point A and then from point A to point C. So if we have to find the distance that the object has traveled, what do? We actually add the distance that it has covered. So first it covers a distance of OA, and then from A to C, that is AC. So we add OA plus AC to get the distance covered by that object, which comes out to be 60 plus 35, that is 95 kilometers. Now, if we have to check the displacement, so in this case, what is the start point? Start point is O, isn't it? The start point is O. What is the end point? End point is C. So what is the shortest distance between O and C? It is OC. And how much is OC? It is 25 kilometers. Hence, in this scenario, the displacement is 25 kilometers. Okay, so a few notes with respect to distance and displacement. So distance gives us the overall motion, whereas displacement helps us to locate the object's final position with reference to its initial position. And this is quite important. In this case, distance and displacement both have same SI unit called as meter. So are you introduced to SI unit thing? So those are the standard units. SI stands for System International. Okay, so every physical quantity that we will get introduced will have its own SI unit. So both distance and displacement, they have SI unit of meter. Okay, and that M, whenever you refer to meter only by the letter M, always remember it has to be the small letter M. Okay, and one more thing before we proceed to the next slide. Displacement needs both magnitude as well as direction. Whereas in case of distance, only magnitude will help. Okay, so you're already introduced to integers. The way in case of integers, they tell us that if we have +5, so +5 lies to the right of the 0, whereas if we have -5, it will lie to the left of 0. So that plus minus signs, in a way, they give us a sense of direction. So displacement needs both direction as well as magnitude, whereas in case of distance, simply the magnitude. For example, distance between Pune and Mumbai is 150 kilometers. It is the distance. Okay, but if you remember, or all of us might be using GPS quite often, so you must have seen. So there it actually gives us direction as well. So it tells us that you should go 100 meters east,